everyone, this is your math guru. In this video, I'm going to show you how to simplify the following trigonometric values. We have if sine 17 degrees is equal to A, without using a calculator, express the following in terms of A. 1, tan 17, 2, sine 107 degrees, and then 3, cos squared 253 degrees, plus sine squared 557 degrees. I'm going to start with the first statement, which says sine 17 degrees is equal to A. 17 degrees is an acute angle, so therefore that falls in the first quadrant. I'm going to draw that quickly here. So this will be my angle, 17 degrees, y-axis and x-axis. If I interpret what is written, and I have sine 17 degrees is equal to A. A is a whole number, so that's over 1. And we know that on the trig ratio, if I'm using my SOHCAHTOA, that's SOHCAHTOA, the acronym for remembering the ratios of each trig function, sine is opposite over hypotenuse. So what this means is my opposite will be A and my hypotenuse will be 1. The side facing the angle is the opposite, which in this case will be my A, and the longest side will be the side facing the right angle triangle. That will be my 1. So therefore, before I go ahead, I'm going to find my adjacent as shown. Using Pythagoras theorem, I have the hypotenuse squared is equal to the square of the sum of the other two sides, that's my adjacent squared, plus my opposite squared. My hypotenuse, or making my adjacent, which is the value I'm looking for, the subject of formula, I have my adjacent squared equals hypotenuse squared minus my opposite squared. So what I mean is, my hypotenuse, 1 squared, minus the opposite, A squared, is equal to my adjacent squared. To find my adjacent, I'm going to square root both sides, which means my adjacent is equal to the square root of 1 minus A squared. So I'm going to put that back into the diagram. The adjacent will be the square root of 1 minus A squared. So going back to the first part of the question that says find tan of 17 degrees. Tan, using the acronym for the trig ratio, tan is opposite over adjacent. The side facing the angle, that's my opposite O. The longest side is my hypotenuse, H, and the last side is my adjacent. So therefore, tan 17 degrees will be opposite, that's A, over the adjacent, that's root of 1 minus A squared. That's equal to tan 17 degrees. The second part of the question says, find the value of sine 107 degrees. So I have sine of 107 degrees. I'm going to use my reduction to break that down. If I go back to my cast diagram, C, A, S, and T, in the first quadrant I have theta, in the second quadrant I have 180 degree minus theta, or 90 degrees plus theta. In my third quadrant I have 180 degrees plus theta, and the last quadrant 360 degrees minus theta. Note that sine of 107, that's an obtuse angle bigger than 190 but less than 180, and that falls in the second quadrant. So I'm going to use the cofunction 90 plus theta to break that down. So that becomes, that's equal to sine of 90 degrees plus 17 degrees. Note that 90 plus 17 will give me back my 107 degree. And using the cofunction rule, this is equal to cos of 17 degrees. We know that the trig ratio for cosine is adjacent over hypotenuse. And if I go back to my diagram, because I'm using the same acute angle 17 degrees, my adjacent will be root of 1 minus a squared, and my hypotenuse is 1. So therefore, my sine of 107 degrees, which is now equal to the cosine of 17 degrees, will be equal to the root of 1 minus a squared. The last but not the least example, I have cos squared of 253 degrees plus sine squared of 557 degrees. I'm going to solve each term separately so that you understand better. I start with the cosine of 253 degrees. If I break that down using my cast diagram, that angle 253 degrees falls in the third quadrant. I have my first, second, third, and my fourth quadrant as shown. And the breakdown will be to cos of 180 degrees plus 73 degrees. I'm going to put that inside. And because in that quadrant, cosine is negative because only tangent is positive in that quadrant. So that's been reduced to negative cosine of 73 degrees. If I go back to my right angle triangle, I have the angle 17 degrees, 90 degrees. Sum of angles in a triangle add up to 180. So to find my last angle, that will be 180 degrees minus 90 degrees plus 17 degrees. And that's equal to 180 minus 107 degrees, which is equal to 73 degrees. The reason being sum of angles in a triangle plus that. So what that means is the last angle in my triangle will be 73 degrees. So therefore, I'm going to change the sides, because if I'm using 73 as my reference point, the only side that doesn't change is my hypotenuse. But now the side facing my 73 degrees will be my opposite, that's O, and the last side will be my adjacent. For my trig ratio, cosine is adjacent over hypotenuse. So that is going to be equal to minus cos 73 will now be adjacent A over hypotenuse 1, which is negative A. I'm going to do the same for my sine 557 degrees. Reducing, I need to see how many loops of 360 degree I have in 557. So that will be sine of 360 degrees plus 197 degrees, which falls in the first quadrant. So that's equal to sine of 197 degrees. Now 197 degrees falls in the third quadrant, which means I need to break that down into the sine of 180 degrees plus 17 degrees. Note that sine is negative in that quadrant, so this resolves to negative sine of 17 degrees, which we've been given as from the first part of the question. Sine 17 is A, so therefore this is negative A. So with this information, I can solve that question that says cos squared of 253 degrees, so that resolves to, I'm going to say, minus A all squared plus sine squared of 557, that's going to be minus A again all squared, which is equal to A squared plus A squared, and my final answer will be 2A squared. So this is equal to 2A squared. Please don't forget to click on the like and subscribe button below for more easy to understand math concept. Thanks for watching. Bye.